In this video, we're going to learn how to analyze a series circuit and looking at the three main laws of a series circuit. Here we have a simple circuit with the three components that every circuit must have. We have a power source, our potential difference, we have conductors, and we have a load. On this side we have the potential / the voltage source in between those two plates, and on this side we have a load, or which restricts the electron flow from the negative source to the positive. We're going to say that this has 12 volts potential across the battery, and there's going to be 12 volts potential across this load. So our PD, our potential difference, equals 12 volts. Electron flow, we go from the negative through the loads and back to the positive. If we used a voltmeter and we put it across our potential difference, our battery, this would obviously read 12 volts. Yes. If we moved it farther apart, what would the voltmeter read now? That's right, still 12 volts. And if we went farther down the load, what is potential difference between these two? We would still have the potential difference, or the voltage across those, or between those 2 points, as 12 volts. And as we get closer to the load, the potential difference is still, you guessed it, 12 volts. And then right across the load, we're going to measure a potential difference of 12 volts. So what would be the current through the circuit? We can use Ohm's law to calculate this. If our resistor was 12 ohms, we've decided that the potential difference across the load would be 12 volts, which is the same as the potential difference from our source. And using Ohm's law, we're going to say there's 1 amp of current flowing through that resistor, which is also from the source and back to the source. And we're going to break this resistor into 2 even loads. And what would be the current through this circuit? Well, as we just said, if it was the same resistor that we just broke in half, it would be like adding those 2 together. So our resistance series law, or series resistance law, is the resistance total in any series circuit is equal to the resistance of all the load's resistances added together. R1 plus R2 plus R3. So in this case, 6 plus 6 is back to our original 12 ohms. We have 12 volts across both of those resistors, from the black to the red, and that means we have 1 amp flowing through the circuit. Now if we can take a look at the series current law, where the amperage in any part of the series circuit is equal to the amperage in any other part of any other circuit. So here we would take our 1 amp and put it into both, going through both loads, and from here we can calculate, using Ohm's law, calculate the voltage across each load. And there we have it. Now if I take R2 and break it into 2 parts, but they're not going to be even, they're going to be 1/3 and 2/3. So I'm going to have a 2 ohm resistor, 4 ohm resistor, and a 6 ohm resistor. So series resistance laws, again, we've got R1, R2, and R3. Let's add them together. And we come back to our original 12 ohms. We have a 12 volt potential across all of our load. What is the current through there? It's going to be, of course, back to our 1 amp. Series current law, you got it. IT equals the current through I1 equals the current through I2 and equals the current through I3. So let's insert that there, and there, and there. And now we can calculate the voltage across each one of those loads using Ohm's law. 2 volts for the 2 ohm, 4 volts for the 4 ohm, and 6 volts for the 6 ohm. So what does the voltages across each resistor add up to? Well, we've looked at our series resistance law, we've looked at our series current law, and now we're going to look at our series voltage laws. ET, the total voltage in a circuit, has to equal to the potential difference, and it is the sum of all of the voltages of each series load. So the series resistance law and the series voltage law are very similar. So calculate the current through each resistor and the voltage across each resistor using those laws we just looked at. There's our 3 laws. In this circuit here, we need to look at what is our potential difference. It is still 12 volts, but our loads are a bit different, so we have to use our series resistance law first. Let's calculate 2 plus 4 is 6 ohms total in the circuit. Our potential difference is 12 volts, and so our amperage through this circuit is 2 amps. Now we can look at our series current law and realize that if we have 2 amps anywhere in the circuit, we have 2 amps through each load. And now with Ohm's law, we need to have 2 knowns to find the third unknown. So here we have 2 amps and 2 ohms. We're going to use Ohm's law to calculate the voltage across the 2 ohm is 4 volts, and across the 4 ohm is 8 volts. Now we can check that to say that our series voltage law, does the voltages across R2 and R3 add up to our potential difference? And 8 plus 4 is 12. So here's one you can try for yourself. Calculate the current through each resistor and the voltage across each resistor. Here's our 3 series laws and 3 different resistors. We're going to find out what the total resistance is in that circuit first. So using series resistance law, 6 ohms, still 12 volts. Calculating the current through that using Ohm's law is 2 amps. If series current law, has to be the same current in each circuit. So let's put those in there. Now we can use Ohm's law to calculate the voltage across each resistor. And then using series voltage law, does the voltages across each resistor add up to our potential difference? And 6 plus 4 plus 2 volts does equal 12 volts. Here's another one. I'm going to give you a minute to calculate this out using the same methodology. So your RT should have come out to 24 ohms. And in this here, I'm not telling you what the potential difference of the source is originally, but here we know that I'm telling you it's 24 volts across the whole circuit. So we can find Ohm's law using finding the amps. Now what do you do with the amps? They have to be the same for each one. So put your amperage in the right position in Ohm's law. And now, using Ohm's law, calculate the voltage across each one of those resistors. Adding them all up, the voltages add up. 12 plus 8 is 20, plus 4 is 24. Here's one more for you to practice with not everything shown as we did before, but we're going to use the same laws to solve this circuit. If I have in R1 5 amps through it and it's a 12 ohm, there's something I can use there, the series current law. If I have 5 amps in R1 or going through R1, I have 5 amps through R2 and 5 amps through R3. So let's put that in there. And I also have 5 amps in my total circuit coming out of my power supply and going back in. Now in the top R1 I can see I have 2 values I know there, and in R2 I have 2 values I know there. So let's calculate those, the missing or the unknown for R1. Ohm's law, 5 amps times 12 ohms means there has to be 60 volts across it. And in R2, that has to be an 8 ohm resistor. 40 divided by 5 is equal to 8. And now I can rearrange my series resistance law, that if R1 and R2 are 20 and the RT is 24, R3 must be 4 ohms. Now with R3 and the total circuit, I have 2 of the 3 known. Calculate the last 20 volts across there. And if I add all those voltages up using my series voltage law, I have to have 120 volts across there. Or I can multiply 5 amps times 24 ohms to get 120 volts.